Welcome to Lewis Structures. This is our 6th video in Unit 3. It's actually like our 7th, but it's our 6th concept. Very important concept, but yeah, let's go. So, we've talked about electrons being shared, and to represent how they're actually shared within a compound, like what atoms they're shared between, etc., we construct Lewis dot structures, named after G.L. Lewis or something. Basically a guy with the last name of Lewis. So, in Lewis dot structures, electrons are represented both by dots and dashes. As you can see here, we have dots. This is a Lewis structure, by the way, and dashes. Yep. So, when drawing Lewis structures, the following steps will help. First off, sum up all the valence electrons from all the atoms. I don't know why I just circled that so much. Or else I'm going to try using the lightsaber again. Okay, I'm so tired of that sound. Never mind. Okay, no lightsaber. So, sum up the valence electrons from all the atoms. For example, actually we'll get there in a bit. For anions, add additional electrons. For cations, subtract electrons. Because look over here. Sodium has this one little electron that it really wants to give away. And it starts with 11 electrons. When it gives that away, it has 10. So, it's count up the actual electrons, but cations, keep in mind, you are going to lose electrons, and anions, it'll gain one, so you actually add electrons. So, add them all up. Next one, write these symbols for the atoms. And then, we show which atoms are attached to which by connecting them with single covalent bonds. Basically, put a dash between them. Connect them, these represent 2 electrons being shared. Now, we complete our octets around all atoms. You're like, wait, Ms. Ruth, what's an octet? Well, it basically means every atom wants 8 electrons total touching to it. Except for hydrogen, which is fine with 2, and boron, which is fine with 6. So, when we look over here, we have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6. Like, wait a second, you already counted those bonds. I know, they're sharing. That's how covalent bonds work. Get over it. That is how Lewis structures go. Trying to think of common issues I've seen. Oh. Hopefully you'll remember that fluorine normally has 7 valence electrons and boron has 3. Once you connect them, try to imagine all of them are now 0 and you only count the bonds. Otherwise, it gets really confusing. So, I'll show you in a bit what I mean. Okay? And if you have any leftover electrons, wow, these numbers are like freaking out. Whatever. Any leftover electrons, just put them on the central. There are going to be times where that will get you more than 8 electrons. It's okay. It's fine. Just any extra, go on the central. If you don't have enough, however, to finish the central, that's where you're going to need some stronger bonds, like double bonds or something. You basically take some of the pairs that are only on 1 electron or 1 atom and share it between them. That way it counts for both of them. And double bonds, again, count for 4, and triple bonds count for 6. Lastly, if a compound is a polyatomic ion, put its formula in brackets, because what you're saying is this is possible only if we gain 1 more electron. So you need to make sure that people know that. All right, let's do some Lewis structures. Okay, oxygen has 6 valence electrons. We had a previous video that showed you how to count them. Feel free to watch that if you can't remember. For just single atoms, it's a little bit different. So that's kind of why I'm showing you. Every side needs to have 1 electron before any have 2. Kind of back to Hund's rule. So we have 1, 2, 3, 4, 5, 6. You can put, basically I'm going to be looking for 2 sides to have 2 and 1 side to have 1, or 2 sides to have 1. You can put 2 over here or 2 over here. I really don't care. You just need 2 sides to have 2, 2 sides to have 1. And I'm going to pause now and let you try arsenic. See if you can do it. All right, hopefully you've tried it. So let me show you how you do it. Arsenic has 8, so technically 1, 2, 3, 4, 5, 6. Okay, I'm just going to erase that. That was bad. basically, you'll have 2 on every side. So 1, 2, 3, 4, 5, 6, 7, 8. There you go, arsenic. All right, let's try hydrogen monochloride or hydrochloric acid. HCl. Okay, we start by putting a covalent bond between them. And actually, before that, we need to figure out how many valence electrons. Hydrogen has 1. Chlorine has 7. Total of 8. Now notice, we've already put 2 electrons, though, in this bond. So that means we have only 6 left over. Hydrogen has 2, and it's happy. Chlorine has 2, but it wants 8. So we need to actually put all 6 of these around chlorine. And that is our Lewis structure for chlorine. It's a little weird, I know. You'll get it with practice. But let's try one more, and then I'll let you try a few. Okay? Let's try H2O. So, H-O-H. Now, I'm going to ask you in a bit, but actually, no, I'll just tell you. You're probably thinking, wait a second, how did I know the O is in the middle? Why can't I just do this? What I'd like you to realize is I have 2 electrons here and 2 electrons here, which means a total of 4 on hydrogen. But hydrogen only wants 2. You'll actually find that hydrogen is normally on the outside of the structure because it only wants 1 single bond. So that brings us back to H2O. We have a total of, every hydrogen atom brings 1. We have 2 of them. 1 oxygen for a total of 8. So 2, 4, 6, 8. And that's H2O, which is water. So I'm going to pause and let you try this one. And feel free to try these if you'd like. So I'll go ahead and pause and let you try them. Okay? Hopefully you've tried them. So let's get moving on. So we have CH2O. So we have a total of 4 for carbon, 1 for both of our hydrogens, and 6 for oxygen. That gives us 4 plus 2 plus 6 for 12. So C, H, H, and O. Carbon normally goes in the middle, and you just know that from experience. If you can get oxygen in the middle to work, sure, have fun. So we have 12 that have been placed. That gives us leftover 6. Hydrogen's good. Hydrogen's good. Oxygen only has 2, and we start on the outside. So yeah, we're close to getting carbon, but let's get oxygen first. So oxygen needs a total of 6 more. So 2, 4, 6. Gonna darken those a little bit. That leaves us 0, but we're like, wait a second. Carbon only has 6, and we don't have any more electrons to place. This is where you form a double bond. So you take one of these pairs and kind of put them here. You basically tell oxygen to actually share a little bit more. So double bond, and I'm for some reason not able to erase this, so I'm just going to scribble it out. And it doesn't even want to scribble it out well. So there you go. All right, let's try the next one. NH4 plus. Okay, N has 5, hydrogen has 1, and there's 4 of them. And that plus means we gave away 1 electron. So this is basically like minus 1. And that gives you a total of 8. So N, H, 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 and H. So we have 2, 4, 6, 8. All of them are out. But fortunately, nitrogen is touching all of them. So that means nitrogen has 8. Each hydrogen has 2. We're done. Except we got to do that. That's how you do NH4 plus. Sorry, by the way, about the numbers not quite working. In my later videos, I've fixed them. Hopefully you kind of know what I'm talking about, though. So, let's try our next one. So CO3 2 minus is 4 plus 3 times 6 plus 2, since we have a negative charge. And that gets us 24 electrons. So C, O, O, O. And then we start placing electrons around the oxygens, and we'll come back to carbon. So we get oxygen on the right has 2, 4, 6, 8. Then we have 2, 4, 6, 8, 2, 4, 6, 8. We have a total of 24 already placed. We do have a slight issue because carbon does not have enough. So we need to take one of these, erase them, and make a double bond. And there you go. Also, don't forget this part. Sorry. That's CO3 2 minus. For our last one, let's do SO2, which is 6 plus 2 times 6, which is 18. S, O, O. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. We're still missing 1, so we need a double bond. There you go. That's SO2. I highly recommend rewatching this if you're at home. A lot of people tend to get stuck with these. They mainly just come with practice, so you'll be getting definitely homework on it. But that's Lewis structures. So last little tidbit of information. If we have multiple ways to draw a structure, like we actually did in the last couple, all different correct options are called resonance structures. Like notice we could put a triple bond on the left or on the right, or actually have 2 double bonds. They're all correct. You see that little arrow? We put that between resonance structures. That actually is supposed to be right here. We're down here. We have double bond on the bottom, or the top, or the right. Those are resonance structures. So let's draw all the possible resonance for nitrate. Okay. So we have N, O, 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 which by the way is 5 plus 6 times 3 plus 1, which gets you 24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Wow, I counted that wrong. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then one of these needs to be a double bond. So I'm actually going to, redraw this real quick. See, told you it's pretty fast. It's like I can, stop time or anything. So these are the 3 resonance structures. Notice the only difference is just where we put the double bond. Normally the arrows are actually all going to be one horizontal thing. I just couldn't fix it. If you really want, you can put 2 arrows. But yeah, that's resonance, just the same way, or a different way to draw basically the same thing. Lastly, ozone molecules. All the resonance structures. So O3 has 18 electrons. So we have O, 2, 4, 6, 8, 10, 12. Hang on. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Which means we need a double bond somewhere. Why is this not erasing? It's getting really annoying. But we also could put the double bond on the right. And there you go. So those are resonance structures. They're just basically Lewis structures without it, with multiple options. You will know you need resonance structures when they say stuff like draw all the resonance structures. But there you go. That's it. All right, and for the practice for this video, I'd like you to do the Lewis structures for any 4 of the following molecules. If you'd like to do more, I'll still help you and still give you feedback all you wish. If you're at home, you can try all 8 if you'd like. But if you're in class, I'd like you to get at least 4 of these. Cool, have a good time. And as always, thanks for watching.